I really do not want to waste Romain's time because we are already a bit late and we will have some food at 7 p.m. So just a few words about the fact that I'm really happy to see so many R users or aspiring R users here, and to know that the Budapest R user group has more than 200 members just after the foundation, which was like a year ago. So this is great. Thank you very much. And I'm even more happier to introduce you Romain Francois, who will give a very exciting talk about R and C++ integration.
See about that.
I'm pretty sure about that. It will be really, really exciting. So I don't waste your time anymore. Please, the stage is yours, and okay, let's start.
Okay, so I've prepared for something like 1 hour. Is that too loud? Which means that it could run from anything like 30 minutes to 90. So please feel free to interrupt me at any time if I'm boring. That could happen. So let's zoom in a bit. So wherever I go, I take a picture of a bridge and I use it as my cover slide. This is not a picture I took, so I'm cheating a bit on there. I tried to take pictures of some bridges yesterday evening, but I couldn't achieve something that was pleasing enough for my taste. So I just took some picture from the internet. Right, so today I'm going to talk to you about R and C++, which is something that's been on my interest for quite some time now. So this is my name, that's my Twitter. We'll talk about this in a minute. The reason why I choose a bridge for my cover slide is that what I'm going to show you is essentially a bridge between R and C++. So that's kind of the reason why I use that imagery. Yeah. So let's get going. So this is me. I was something between 2 and 6. I'm not quite sure because it's a picture from the ages where there was no data with the picture, so I have no idea. Maybe my family does, but that's a kitten. I've been using R for something that feels forever now, which is 2002, so way before it was cool. Maybe I shouldn't drink. What I do for a living is I consult. So I write code for people, R code, and then sometimes C++ code for people. I try to solve their problem or make something faster than what they already have. It's been running. I've been doing this on my own for 5 to 6 years now, and I get good years and bad years. It just depends how motivated I am at the time and whatever. I've been involved in this RCPP thing for 4 to 5 years now. 4 years. The project existed before I was involved with it, but it was really smaller, and I do like to say that I'm a big part of what makes it pretty nice these days, but so much for bragging. I will also talk to you about a different one, which is RCPP 11. I'll talk to you about this at the end of the talk, hopefully, if I still have time. This is something I've been involved recently, kind of getting away from the RCPP team to focus on more recent C++ standards. So I've been focused on RCPP 11 for the C++ 11 standard, and now I'm going to start working on RCPP 14 as well for the C++ standard that was released like a few weeks ago. Why do we care about C++? It's because it makes the code much faster. One of the frustrations some people have with R is that sometimes it's slow. And for a certain kind of problem, it can be really slow. So with C++, you can have much finer control of what you do with the copy of the data and things like this. So you can manage to have your code much faster. And it's like there's no guilty conscience about writing a loop. When you live in C++, writing a loop is like what you do. So you don't have to feel guilty about stuff like that. I would occasionally do comedy, although not tonight. If I say something funny, it's by accident tonight. I didn't prepare jokes or whatever. So that's me when I do comedy. So I do need the extra tie and the jacket for the confidence, otherwise I can't be funny enough. Anyway, so what I'm trying to put myself up to is to do a keynote speech at one of the next Use R conference, so either in next year or the year after that. And I'm going to try to mix R stuff, so talk about RCPP and doing the talk that I'm doing right now, and do jokes at the same time. I'm not so sure how this is going to work, because this is not the same kind of people going to a random comedy bar and want to learn R stuff. Anyway, so what I've been doing for that goal is start some propaganda on Twitter. So if you go to my Twitter account, anyone here on Twitter? Right. So those of you who are not on Twitter, please get a Twitter account. And when you are there, you go to my account and you do whatever it takes to promote that. So you make a fab or you retweet this thing, so that eventually they'll pick up that they need to invite me to make a talk, to have some proper, R and C++ and jokes and stuff. So please, I'll put the slide back again at the end of the talk, because that's kind of the main reason I'm here, really, to do my propaganda. Right. So much for that. So what I want to talk about tonight is, so there's two things. There's R and C++ in general, so what we've done with the other people to make it possible and easy and fun to work with R and C++. And the second part is more what I've been involved on my own to move on towards more recent versions of C++, so C++ 11 for now and C++ 14, whenever I feel I want to start on that. And maybe I'll do RCPP 17 in a few years, whatever. I have a lot of free time, so I can do that sort of stuff. So that's, before I get started, that's a copy from the presentation from John Chambers I need to stop with my hands. At the latest Use R, he made a really nice hour-long presentation on his visions of R. The visions he had like 30 years ago when he started working on S, and the visions he still have now about the language. And his whole talk turned out to be quite an avenue pitch for RCPP, so I was really pleased about that. The main idea of his talk was that R is really nice, obviously, but sometimes you want to use R with something else. Sometimes you do this because you want nicer graphical interfaces. Sometimes you do this because you want performance. What we do is performance, obviously, with C++. So that's one of his last slides. Yeah, so essentially the idea is, that's what I've been telling before, is that what we've done with RCPP and now with RCPP 11 is something that makes it easier and better for you to use compiled languages such as C++ together with R. So you can have all the flexibility of R that you like and care about on a daily basis. You can do graphics and stuff like that. You can have all the fun that R gives you. But when you want to go down to have some performance, we make it easy for you to do that. You only have to focus on writing your C++ code and not on, the plumbings of how to convert R objects into C++ data structures. And hopefully I'm going to try to convince you about that. Another quite interesting talk at Use R was the talk from Dirk. Dirk is the maintainer of our RCPP, so obviously this is really biased. So he also had an invited talk. That's one of the reasons I'm doing some propaganda, is I want to be there too, but whatever. So one really interesting thing about his talk, and if you spare all the noise from the usual beamer, if you just look at the graph for 1 minute, that's the... So on the x-axis, that's time, and on the y-axis, that's the percentages of packages on CRAN that depend on RCPP at that time. So you can see that the number of packages grows, and also the number of the frequency of packages also grows, and pretty soon, well, Dirk's joke, and you have to excuse me for using joke of some German guy. I mean, I'm coming to you saying, all right, sometimes I do comedy, and then I borrow some jokes from a German, so whatever. So his joke was that pretty soon we're going to hit 5%, which is good because now it's going to be statistically significant. But I'm not delivering the joke well, but it was pretty nice. Maybe I did it on purpose, so that, whatever. Okay, so talking a bit about why RCPP has been a success, right. If you want to do R and C or R and C++ code without using RCPP, that's a pain. That you have to write lots of crap. And one of the things I discovered earlier when writing those slides is that if you pronounce CRAPI, that means that says crappy, right? And that's pretty much how I feel about the standard way you would connect R and C, or R and C++. That's really the same thing for that purpose. And by the same token, how I want to pronounce RCPP now is something more like recipe for making your code faster and more performant and fun and whatever. All the good things. Right, so RCPP is really a thin layer around the API that R gives you, the crappy, but it makes it much nicer for you to use. And I'm going to stop saying that. I'm going to try to demonstrate it to you to some extent. So you only have to focus on what you want to do, and RCPP focuses on how to convert various data structures from R, a numeric vector, a function or whatever, into something that you can use in your C++ code. That's right. So a few sort of case studies of some software that use RCPP without you really knowing about it. And well, how professional is it to make a screenshot with the Facebook tab on, whatever. So Shiny, anyone used Shiny before? Show of hands. Then all of you who have not used it, you should definitely have a look at it tomorrow. Well, tomorrow you should have a look at RCPP, but then the next day you should be looking at Shiny. That's a really cool way to make your data express itself. Through you write R code and it creates buttons and sliders and stuff, and the graph automatically updates and everything. That's really cool. That's a really cool way to make your data express itself. Right, whatever. Shiny is not about having something that's really fast or whatever. It's just having something that nicely displays your data and something you can interact with. I'm using this example because that's not something where performance is really the focus. But underneath all that cool stuff, there's some RCPP going on. So that's why I'm using this example. Some of the underlying parts of the server they use has some RCPP code in it. Another example, and I'm a bit more biased about this one, is dplyr. So anyone has used dplyr? Right, so on the third day, so what day is it today?
Friday.
Right, so Thursday you learn about RCPP, tomorrow. Then Friday you learn about Shiny, right? And then on Saturday, I'm sorry, but you're going to have to go through this. On Saturday, you need to learn about dplyr. Dplyr has really changed the way people work with data, essentially. It's a really cool thing, and I'm not just saying this because I'm involved in the development, but it's really cool. That's dplyr, and maybe you can vouch for this, but dplyr was one of the big things this year at USAR. You should definitely check this out. And so it's a bit like plyr. People know about plyr? Right, so on Sunday. But much faster. And the reason it's much faster is that because underlying all that coolness, there's some RCPP. So it's there's a theme there, I guess. You get people doing cool stuff, and then underlying that, there's some RCPP stuff going on. You should definitely check out dplyr on Friday. And Shiny on Saturday. Do dplyr first. That's better. Whatever. So there you go. I'm going to show you a few examples of C++ code. I'm not necessarily going with the assumption that you all know C++. Everybody has used C++ before? Right, so next week, you should all learn C++ for like a week. So, I didn't run with the assumption that everybody knew C++, so I'm using really small example code. Right, so that's a C++ function. It takes two integers, which we call int in C and C++, called a and b, and it returns the sum of those two things, and the function is called add. Right, so the difference between when you write R functions and when you write C or C++ function is that everything is typed. So A and B you have to give the type of those things. You have to say that those are ints. And you also have to express what's the type of the thing that gets returned out of the function. And that's a good thing. In R, you can just do whatever you want. And sometimes it's good, and sometimes it's also nice to be explicit about what happens. Right, so that's a pretty simple C++ function. Okay? And, right, okay. So what I'm showing next is a graph which for some reason has cats on it. Whatever. I like to show this graph without axes and stuff, so that I can tell the story about this. So this was from my Use R presentation, not this year, but the year before in Spain. So on the x-axis, that's a loose version of time. The scale is not correct. It's just 1, 2, 3, 4. I was lazy about this one. And on the y-axis, that's the number of extra characters, so keystrokes, you have to type in to make that function I've shown you before, this one. So those are the number of keystrokes you have to add to that function to make it available to the outside. Right. So a few years back, you had to type a bunch of crap there, 250 characters, and now we don't do pretty much nothing, right? A few 40 characters or something. Yeah, I'm not saying lines, I'm saying characters, and those are the same all the time, so you get used to them. Right, and that's what it looks like. So that's the function we want to make available to the outside. We, on the top there, are saying we want to use our CPP. We want to use the classes and the functions that our CPP provides. And then the other line, so this guy here, is just saying that whatever comes next, I want it to be available on the outside. And that's it. That's the only thing you have to do. You say, I'm using RCPP, and please make this function available. And then what happens, right? When you type that thing on your R console, then you can use the function. I mean, there's no, I can show you. Why do I keep doing that? Right. Is that big enough? Okay. So, yeah. I'm using VI just to show you I'm not cheating about anything. And obviously this will backfire. So I'm using RCPP. That's my function. See, I didn't even need to copy and paste. That's how easy it is. I do that. And then what I do is I'm saying, and once you use with the syntax, that's fine. I mean, that's the only thing you have to remember. And then if you add some, whatever, let's not overdo this one. Right. So that's my C++ file. I'm going to save this. See? No cheating about anything. So I'm loading, well, pardon my French, as they say. So I'm loading RCPP, and then I'm doing that. It takes a bit of time, obviously, because it compiles the function with a C++ compiler behind the scenes for you automatically without you having to worry about any of that stuff. And then you end up with an R function called add that does some internal stuff you don't need to know about. And then we can do that. Yeah. Well, that's a pretty convoluted way to add two numbers. I give you that. But I just wanted to have the simplest possible example. Let me go through this again with an extra. See, now I'm overdoing it. Right. what I want to do now is to show you what's happening behind the scenes. So if you add the verbose argument, those are useless. Right. True like this, you'll see what happens behind the scenes, what code gets generated for you, what RCPP does for you automatically, so that you can only focus on writing your code and use it. Right. Let's go back a bit. So the first thing it has to do is take your code and convert it into something that R can understand. The CR API, the crappy thing. So first of all, it has to write stuff with SEXP all over the place. So that's what R understands, right? That's function taking any number of SEXP thing. SEXP is like an R object, and returning that, and that does a lot of stuff. I'm just showing what you are getting away from. I'm not expecting you to be typing any of that code any soon. It does for you protection of R objects automatically, so that you don't have to worry about garbage collection of your objects and stuff. Right. It also generates some R code for you behind the scenes. So loading the shared library that was compiled for you automatically, it loads this thing into an object named this, and then it grabs whatever it needs from that and make it into a function. Right. So all of that stuff, I'm just showing it to you because, I like to show people how much we suffer, so that you can realize that using RCPP is not so much a big deal. But there's a lot of work. I'm not sure what I want to say there, but there's a lot of work involved behind the scenes to make it easier for you to use those technologies. And similarly, all of that stuff is compiling the C++ code that we generated for you, and then loading it into R and everything. All of that you don't need to worry about, and I shouldn't really be showing this. The only thing you need to know is that you can do, let's try something different, you can do 7 and 9. Hey.
And what happens if you do not integer numbers?
Right.
What's the error message?
Like this. So what happens is that the numbers are truncated to ints, and you can either argue that's a good choice or a bad choice, but we made the choice to do it silently without giving warnings or errors. The main reason for that is that so when I type 7 or 9 like this, those are actually right. Those are actually doubles, not ints internally. And if you really want ints, what you do is that you have the capital L at the end. For some reason, that means int. Whatever. I mean, I'm not doing those rules. So we didn't want to impose on people to have to write capital L all over the place, because we don't like that. So what we did is going silently there whenever it makes sense. I mean, otherwise, this does not make sense, right? So at that point, you'll get an error, right? And I'll give you that the error message could be a bit more explicit about what's wrong, but that's something for another time. Something else also, if you try to give it a vector of, well, actually, let's make it a vector of integers to the function. What's right? In that case, it'll give you an error saying that it expects one value, not a vector. I does not make the distinction between a vector and a scalar, but we can make the distinction for you internally in the C++ side. So if your C++ function expects one value and you give it more, that's not going to fly. So we can detect that and act on it. Let's go back there. Right. So this took a bit more time than I wanted, but whatever. You have to stop me whenever I go deep down, because I enjoy doing that stuff, but sometimes that doesn't help me making my case that it's all easy and everything if I go down to these bits. Right. Okay, so for every sort of R data structure you are used to manipulate daily, so vectors, numeric vector, integer vectors, lists or functions or environments or whatever data structure you can have in R, we have a C++ class to represent the data structure in C++. And what we do is that we give meaning to those objects, specific meanings according to what the objects are. And this will be clearer in a second. Because you're not going to want to do the same thing with a vector and a function, right? With a vector, you want to know the size of the vector and what are the elements, what are the data points in the vector. With a function, you want to perhaps call the function. You don't want to do the same thing with those different classes of objects. Right. Okay. So this was one of the key design points of RCPP and other versions of it going forward, is that all of the classes we developed in RCPP, in recipe, let's say recipe, I like to say that, are proxies. That means that they don't have their own data. They are, when you say something to an RCPP object, what it does for you is go to the underlying C object that it's given to you by the C API. Right. And it manipulates this object for you. It does not have its own memory on top of it. It relays the information back to the crappy object. Maybe I shouldn't say that. Whatever. So let's have a few examples of manipulating those objects. Once again, those are really simple examples, just to get started on doing some stuff. Right, so we have a C++ function there called sum. It takes a numeric vector as input. So as in R, a vector with numeric data points. And it returns a single double. That's a real number. And what the function does, even if you've not done C++, you can pick it up. It calculates the sum of the elements in the vector, right? So what's interesting about this is that because we are saying that X is a numeric vector object, so numeric vector is something that comes from RCPP, that's an RCPP class. Because you say that, you can use the class to extract things out of the object. So for example, you can do dot size, that gives you the number of elements in the object. conveniently. And the other thing I've put in yellow there, bracket I bracket. Obviously, it gives you the value in that position in the vector. I cannot emphasize this more. When you are working in C++, the first element is at position 0 and not 1. I mean, once you've been through a few bugs involved when writing that sort of code, once you've, scratch your head a few times, then you can get used to it. It's just, you can think of this as an offset from the start of the vector. Right, so what I'm doing here is I'm creating a new variable called res, initializing it with 0, and then I'm doing a loop. Once again, there's no guilty conscience about doing loops in C++. That's what you do when you write code. And then what I'm doing here is that for each data point in the vector, I'm adding its value to res with the plus equal operator there. Right, so really simple example. Two things that are important is that because you declare your object as a numeric vector, you can get the size and you can extract the value from it. You could also set the value. You can do x, y equals something if you wish. I don't think I have an example of that because I really wanted to stay generic enough. An example of using lists. So lists are really cool in R. You can put any random whatever object in a list. And we've tried to have something useful for that in RCPP too. And maybe I'll have time to show you that in RCPP 11 we have something even nicer. Whatever. So you do list column create, and now you create a list with that syntax. So there's a bit of, you need to stomach a bit of the syntax, right? But I mean, once you get used to that underscore brackets name bracket equal, once you get used to it, it starts to make sense. Because we have to play by the rules of C++ here. We can't have just we can't just have b equals something because that's not valid C++ code. But that's close enough. And I mean, you can sort of read the code there. You can understand that it creates a list with two elements. The first one is called A, and it's going to be integer vector with one value, and that's 1. And the second element is called B, and that's going to be a character vector with one element, and the element will be foo. Then also you can manipulate attributes of the object. That's not specific to list, but you manipulate the attributes with a dot attr. So that's the name of the attributes if you wanted to make an S3 object, for example, of class myClass. Then you can extract things from the list. So you extract the A and store it in an int. Or you can replace the value of B with 42, right? Or something. So it gives you convenient ways to manipulate lists. And in C++, that's C++ code. That's not R code or whatever. That's and writing that, manipulating lists without that would be quite more of a challenge. Right. So functions. Another example: manipulating R functions down in the C++ layer. Sometimes you want to do this. For example, you do optimization, and you want to call your R function in a loop within the C++ side. People do that. So what you can do is use the function class. Function, once again, is a class that RCPP gives you. That's not a standard C++ thing. That's an RCPP function, a class called function, whatever. So what you do is that, so that's the name of the R function you want to grab. That's the name you give to the function in C++. So you end up with a C++ object that is a proxy of the R function. And then what you can do with this C++ object is that you can call the R function that lives underneath it with syntax that is close enough to what you would expect in R. I mean, you call the function with the standard round bracket, right? And then you give it arguments. We can't, once again, we cannot do 10 mean equals 30, SD equals 100, because we have to play by the C++ rules, but we came up with something that's close enough, in my view. Right. How am I doing on time? How am I doing on time, you know?
I cannot breathe.
Is that a good thing? Right. Okay, that's all right. This is less than the first bit. Right. So, you okay? Yeah. It reminds me. Well, I'll tell you later. Yeah. So up until now, I shouldn't laugh about that. I mean, that's not funny. Up until now, I've been talking to you about the generic RCPP. So connecting R and C++, the standard way to do this up until now. I've been working on RCPP for 4 years now, and I'm doing less work on it now because I want to focus on newer technologies like C++ 11 and C++ 14 going forward. So what I did essentially is to make another one, borrowing the code base at some point and then just going in some other direction with it. Because writing RCPP, well, at least making what RCPP is today was my way to learn C++. So this has been quite an adventure. That's been fun and everything. But when you write software that people use while learning about the underlying technology, you make mistakes. And I understand these mistakes now, and I think I can do something better. And that's also part of the reason why I wanted to work on RCPP 11. So there's two reasons really: being able to assume a new standard, so C++ 11, and also being able to remove some of my mistakes from before. Right. And that's essentially what I've been telling you before. So I want to assume that when I say C++, it means, don't look this way. So from now on, whatever I work on, for me, C++ will mean C++ 11 or C++ 14. The code base is much smaller because C++ 11 is much nicer to use, and it can be much more concise. So we have lots of generated code in RCPP. So we have R code spitting out C++ code because we can, and we've been able to take some of that away in RCPP 11. And well, header only is a technicality. I'm not going through this, but it will possibly change some of the ways we are using R and C++ in the future. Right, so there's no cats in this one. There's no explanation of the axis either, because I want to tell the story. So those are the number of lines of code, number of lines of C++ code in both RCPP in green and RCPP 11 in red. So if you don't look at this for a minute, what the story I used to tell people when I was presenting RCPP back then was that, look at this, it goes up, that's amazing, look at all the code we've been able to write for you, that's a lot of stuff you can do and everything. And now the story sort of changes to, we can have the same thing but with much less code, and that can make a difference in a few places as well. I mean, you don't really care about having 100,000 lines of code somewhere, but it makes a difference for some things. For example, it makes the code faster to compile. So if you compile this really simple example, it takes like 3 seconds in RCPP, and it takes only about 1 second in RCPP 11. And there's always something you can do with those 2 extra seconds, right? We've been able to simplify a bit of the interface. I'm going quickly on this. So in RCPP, those are all of the constructors you have for vectors. So vectors like numeric vectors and integer vectors and list and stuff like that. We have all of these different ways to create a vector. And looking back at this, I think this was a mistake. I think that there's too much information going on, and it makes it really hard to document and everything. So in RCPP 11, what we've done is that we've replaced some of that with other ideas. Okay, so we have less constructors. We're down to a minimum. But it does not mean, though, that... Right. It does not mean, though, that you can that there are things you cannot do anymore. It just means that you do those things in a different way. Right. So for example, this constructor up there, taking an int and a function pointer and an object. In standard RCPP, you would use the constructor like this. So we want to create a numeric vector of size 10, and for each of the elements, the value will come from calling this function with that value. Okay, not too complicated. But in RCPP 11, what I've done is replace this with a call to the replicate function, which looks a bit like what you would do in R. So instead of having a constructor like this, what we do is that we call replicate. And I do believe that it makes it easier to understand what goes on, especially if you are used to the R function replicate. Similarly, we used to have a constructor taking a range of iterators. So assume you add a vector from the STL there, and you want to create an RCPP vector from it. So in RCPP you do numeric vector f. So I'm creating a vector, and I'm importing all of the values between begin and end from that. Okay. So once again, I mean, you can sort of understand what goes on, but in RCPP 11 we've done something different, which is again relying on an extra function called import. So we do import those iterators into that vector. That's a bit more typing, but it makes it, again, I mean, I'm really biased about this, but it makes it easy to understand what goes on. And then we were even able to essentially say import that data structure into an R object. Okay, so those are a few things that we've been able to add to RCBP 11 to create vectors. You can use the curly brackets to initialize vector. Instead of doing vector colon create, you do curlies and then the values. So that's something that was added to C++ 11. One cool thing is also, let's assume you add two vectors x and y, and from that you want to make a big vector with values from x and values from y. In RCBP 11 we have the fuse function. That's a bit equivalent to the C function in R, but I didn't want to call it C because I don't like functions with like one letter. So I'm fusing those two vectors into one big vector, and also I could do it with scalar values as well, so x, y, and that value. And we've been able to do this with C++ 11 code because some of the underlying new things that are available in C++ 11 allow for that. If we wanted to have fuse in RCBP, we'd have to write something like 10,000 lines of extra code. So once again, we'd have to have R code that generates C++ code that does some stuff for you. Right. So create. I've shown you create before. In RCBP 11. We've been able to remove the redundant numeric vector colon. We just do create. That's less typing, and you can sort of understand what goes on. And we can give names as well with create, similarly to this, but just less typing. So creating a numeric vector with 3 values called A, B, and C with 1, 2, 3. One cool thing in R is that you can do stuff like sapply, and we wanted to have something similar down to the C++ side. And well, the really cool thing with R is that you can have your function define exactly where you are going to call it, right? And so we've been able to have something similar with lambda functions in C++ 11. So once again, that's a bit of something to stomach, right? That syntax, those brackets, and then that, and then the body of the function. But once you get used to it, you have something that's pretty cool to, you have something pretty equivalent to the R code there. So you are applying over this object with that function. So for each value in X, you're going to call that function. Okay? And we could have extra parameters as well, the same way that R does. Because sapply only vectorizes on the first element, and then the extra values are just passed into the function. And we can do this similarly on the C++ side. Okay, and in that example, instead of typing the function in line there, I just saved it into an object called fun. And one of the cool things about C++ 11 is that you don't have to specify what the type of the function is going to be, because the compiler knows about that, and you don't have to tell the compiler what the type of the function will be. You can deduce it. That's why you have auto. Yeah.
And what is auto? What does it mean?
It means whatever it is. Whatever.
So whatever it gives you back,
So
you don't define the type or
yeah, you just. I mean, the compiler will create a type for that thing, a class. This as a class, a lambda function with 3 parameters, with double. That's a pretty well-defined class. But if you had to express with typing what that class is, this will be really painful for you to type. But you don't have to do that. The compiler know about that, and it by saying auto, what you do is that you say whatever that is, I'm fine with it, essentially. Okay, so the versions of RCPP have been going from 0.6 to 0.11 or 0.12 now or something. Those don't mean much. Okay, we just up the value one minor number every time we release it or whatever. With the RCPP 11, I wanted to go something different. I want to release it essentially at the same time when R is released, and the version number of RCPP 11 will be the same as the version number of R. So the current version of R is 3.1.1. That's the last version of R. And so the last version of RCPP 11 is called 3.1.1. So that's sort of my way to say that's the version of RCPP 11 you should use with that version of R. You could use it with different versions if you like, but that's what I would prefer you to do, to use those with the same numbers. Okay. You can get it from Crown. That's like the stable version. And but I do spend a lot of time working on this, and maybe not recently, but it sort of moves really quickly. So what I encourage people to do usually is to use the development version that you can get from GitHub, and with the dev tools, it's pretty easy to get stuff from GitHub with the install GitHub. Right. Yeah, let's not talk about that. That's a small package we have on the side to convert all of the RCPP export that you've added on top of your function to express that you want to make them available to the outside. This used to be a part of RCPP, and that still is a part of RCPP. So in the RCPP package, you have something that deals with that. But for RCPP 11, I wanted to make it really thin. RCPP 11 only has the C++ code that's underneath everything. And the code generation is done with another package called attribute. That's not released on Crown yet, but it's available on GitHub. And that's the package you use to convert all of these RCPP : export declarations into something that R can understand. But the use of it is pretty similar to the use in RCPP. You just decorate your functions with RCPP : export, and you use source CPP if you want to work on the console, and you use compile attributes if you want to work on a package. And well, maybe I should have shown you this. If you want to use RCPP 11 in a package you've been working on, all you have to do is write your C++ code, right? I can't really do that part for you. So you do include RCPP 11, then you do, we have a shortcut, so that instead of RCPP : export, you can have RCPP 11 : export, or you could just do export, right? In the src directory of your package. then what you do is that you express that you need RCPP11 by writing this in your description file. So system requirements, I need a compiler that understands C++ 11, and I need the code from RCPP11. It's a bit unfortunate that it's called linking to, but that's what R gives us. So, I mean, that's the only thing you have to do to get your code using RCP11. And to generate all the boilerplates, all of the generated code that helps R understand what those export declaration means. You use the attributes package and the compile attributes. That's the name of your package. It will generate all of that code automatically for you. Okay. And I'm going to skip this part. Yeah. So that's sort of what I wanted to present. I can do questions. Or yeah.
You said that the compilation process is controlled by R. What happens if I want to link an external library? MySQL.
You what?
In MySQL, I want to depend on external libraries.
Okay. You can still do that. I mean, you'd have. It's documented in the typical R documentation. There's not something RCPP specific. You can do it with R without RCPP, and you can still do it. That's you have to declare a few things in your make-vars file. I mean, we can go through this over emails or anything. It's not on top of my head at the moment, but it's using external libraries is something people do, and that's not. Yeah, we can do it, but that's not something. I mean, that we add value to with RCPP. We don't have something RCPP specific to connect to other libraries. Yeah.
And even there are some R packages which are wrappers around some C++ libraries,
yeah.
right?
Yeah, there's a lot of. I mean, there's many ways to do this. You can either have your third-party library included in your package, and that it gets compiled at the same time as your package. Sometimes you can do that. Sometimes you can't. Sometimes you want to link into a third party, and yeah, R has all of the vocabulary for you to do that kind of stuff. There are countless examples of that. Yeah.
As we have some warm pizza there, I suggest you ask the questions in a rather informal way next to a pizza and beer.
Sure.
Thank you very much, Romain.
All right, let's go. Okay, let me do that. One last thing, so and then we can get on with the pizza. Is that I did my RCPP level. Well, okay. So first of all, let me go back there
To the first slide, right?
Yeah, you need to get on Twitter, and you need to do that stuff, right? So I'm gonna live this on. And another thing is that I did my RCPP 11 tutorial that year at USR. And for that purpose, I printed a few T-shirts. Those are pretty cool. I don't have one for all of you, right? Because those are just some of the T-shirts left from USR. So those are pretty cool. See? Right. So I don't know how many I have, but those are free. You can. I mean, the first one. First few people to ask a T-shirt will get one. Unfortunately, those are only the ones that are left. So that those are only male, size S. Because I did print a few S, a few M, and a few L. But for some reason in the US, all of the L found someone and not all of the S. Because people eat crap food. Having said that, let's go to eat some pizza now.
small things to announce now. One is that after the meetup, we will go to the city central to Élesztő. It's a söröző. If you want to join, please feel free to do so. We will be at around 9 o'clock. And the pub, and it will be really easy to find us. Just look for the guys talking about RCPP. And the other thing, thank you very much for Balabit IT Security for the pizza, beers, soft drinks, and so on, and also for the cool venue. It was really great. Okay, and let's head to the pizza and ask questions to Romain.